Philipp, hi. Can you hear me well?
Hi, yes, I can. Good morning.
Great. It's a pleasure to meet you online. We've seen you a couple of times offline, and you are a frequent speaker of our conference, and thank you for joining us this time again.
Thanks for having me. Yeah, I would love to be there in person, but yeah, not this year.
Let's see what next year brings us, or the year after next year. Let's hope for the best. So, Philipp Krenn is a developer advocate and a part of the infrastructure team at Elastic, and he is a frequent speaker and full text search databases, operations, and security. This is what he speaks about. So, Philipp, today you're going to talk about scale your Elasticsearch cluster, if I'm not mistaken.
Yes, I got the right talk prepared. Good.
Great. So, the air is yours, and we'll see you after the talk. Good luck.
Yeah, perfect. Thank you. So, hi and welcome everybody. Let's dive into some scaling. So thanks already for the introduction. Yeah, my official title nowadays is developer advocate. So I mostly speak about the good stuff. You might run into me on Twitter or discuss or Stack Overflow or various other places as well. I always say my goal are like successful users. So showing you what is possible or answering specific questions that you have. So the questions we'll get at the end, I'll try to leave 5 to 10 minutes or so for that. And before that, I will try to show you what is possible. Just before I get started, everything that I'm showing you today is free to use. So whatever I'm showing you, you can just run the demo and use that in production or for your demos or whatever afterwards immediately. So what I want to dive into is lifecycle management. It's like, how does your data work and live in your cluster? A bit about cold storage and how you can optimize the long-term storage, especially around cost. And then rollups, if you have metrics and you want to pre-aggregate them, how you can do that. So that's pretty much the plan of what I have to, or what I want to show you in the next 40 to 45 minutes. So this is a good reminder because otherwise I might forget. So this is based on Docker. Normally I would be running this on my local machine, but since we're using Zoom to screen share, Zoom will eat pretty much all my CPU. So I am running that on a cloud instance. But to keep the demo simple, it's a single instance. So it's pretty much the same that you would run locally on your own laptop. I just didn't want to do that. Otherwise my CPU would die and everything would be very slow. That cloud instance is still not super fast. So it will be an appropriate demo for like a small setup. So while this starts in the background, we will get to what I'm actually doing here in a moment. Let me just get started on what I want to show you or what we want to talk about, and I'll show you like the configurations and the individual steps in a moment. So lifecycle management, the idea is generally you have some data that has a timestamp, like log event, a metric, maybe a trace. And that data normally has a so-called life cycle throughout your system. If I ask people initially, like, how long do you want to store your data? They will say like 100 days or a year or whatever comes to their mind first. And then you say, okay, based on the amount of data that you generate per day, that will mean that many servers or that much data. And then people are like, okay, that's maybe too much. And I don't want to spend that much money on that problem. And that's where lifecycle management comes into play, where you can define like, how long do you want to keep the data around in general? So maybe for some logs, you might have a retention of 2 weeks. And for other more long-term relevant data, you might have a retention of a month or 3 months or a year or whatever makes sense for you. The idea is to enable that with lifecycle management and also to give you the option to move that to different types of hardware. So for today's data, maybe you want to access that very frequently and very quickly, whereas every now and then you will need to run some search operation across data from like a year ago. You will do that pretty infrequently, and that's why you accept that this might take a little longer. But you don't want to spend that much time on the problem or money. You maybe have to spend some time waiting to get the result back because you want to just have like a cheaper setup for that. So you might use nodes that don't have that much power, but you have more data stored on them just to keep the cost down. So that's the general idea of lifecycle management. You have some timestamp data, and based on one or multiple criteria, you want to keep the data around for shorter or longer, and you might want to move it to different profiles of hardware just to manage cost better. Lifecycle management, how we call that, or we call it index lifecycle management, because an index is the place where we store the data. The little symbols or icons are trying to symbolize hot, warm, cold, and delete. I used to use a skull for the delete phase because then your data is basically dead and removed. But people said like that's too unfriendly, so I'm trying to use that more neutral bin now. So hot, warm, cold, delete. Those are generally the stages, and we call them like that. And we're in the process of formalizing that even a bit more in the stack. So hot is generally the data that comes in right now that you write. It's like today's data or maybe yesterday's data. So this is where all your write operations happen and most of your reads, because you will mostly be interested in like what were the errors in the last 12 or 24 hours. After that, there is warm. It's like data that you access more or less frequently. It might be 2 days to 2 weeks old or so, for example. And then you might have cold data. Cold data is something that you might have to store for compliance reasons, or because your security team wants to do an audit for the past 6 months. You don't actively search that data that frequently, so you accept that it will take a little longer to actually get through that data. So that's kind of like the cold tier. Let's see how we can do that. How we can actually do that, and as you can see, hope this is readable. This is pretty well hidden in the Elasticsearch source code. Where this is hidden, it's in a class called time series lifecycle type. And these are basically the actions that you can call there on the different steps. And you can see we have hot, warm, cold, and delete. So those were the 4 phases that I've already shown you. And then in each one of these arrays, we have the sorted steps of what you can actually do in each one of these steps to manage your data and how it's being managed over the life cycle. So hot is basically, you can set the priority. Priority is not super important. It's just like in case a node restarts, how quickly will the different indices be made available? Like normally you will set the highest priority to the hot data because that's where you do your writes and most of your search operations. And all the data you give a lower priority because you don't need to access them that quickly normally. Unfollow if you replicate to another remote cluster, that would be an unfollow action. Not as widely used because that is one of the few commercial features that we have here. I'm not going to dive too much into that. It's mostly for disaster recovery. It's one region goes down and you want to have another copy of your entire data in another data center. That's where you have concept is called cross-cluster replication. And you could unfollow another data center or index before actually taking any other steps. Then what is much more relevant is the rollover action. So this one probably requires us to dive a little more into how do you structure your data or indices. So in Elasticsearch, you call the thing where you store related data together an index. So you might have like logs. Historically, the initial idea that you might have to store your data is I will create one logs index and I will put all my data there. And after 30 days or whatever your retention is, you start deleting stuff from there. But that is not a very good idea because the way that Elasticsearch and Lucene in the background store data is that it's being stored immutably. So it doesn't change the data. It would, for example, if you would remove some documents from an index, you would just mark them as removed. And then you would wait for a merge to create a new data structure because the initial data structure is immutable. Or the way that Elasticsearch and Lucene write data is immutable. So you would always have to mark data as deleted and could then only in a merge actually get rid of it. And that is pretty expensive. So what you would rather do is you would create, for example, a logs index for every single day, and then all your write operations go to that day. Once you have reached the maximum retention of your data, you might just delete the entire index. So you have logs dash, and then you have 2020, 10, 16, 17, whatever is the date. And then you would just write it there. And once you're done with that data, you just delete the entire index. And that is a very quick operation in comparison. But it has another downside. The downside for that is that depending on the day of the week, potentially, you don't have the same amount of logs every day. So let's assume you have lots of logs Monday to Friday, but Saturday and Sunday, your service is not that much used. So you don't have that many logs. So the indices from Monday to Friday would be much larger than the ones that you have for Saturday and Sunday. And it's not ideal to have these unevenly sized indices. So what you have instead is a rollover. A rollover is basically you can define up to 3 conditions when you want to create a new index. One of them is time-based. So rather than just a day, you could say every 6 hours, I want to create a new index, or every 48 hours, whatever makes sense there. But you also have 2 other options that you can have, and you can combine them any way you want. You could also say the number of documents. So every 1 million documents, I want to create a new index. Or you could say once an index reaches a certain size, like 50 gigabytes, for example, which might make sense. And if you use the beats like Filebeat or agents or shippers for data, that would be the default that we're using by now. So they would create a new index only every 50 gigs of data or 30 days, whatever you reach first. So this is the way that it is set up by default, but I will show you how to totally customize that. So the rollover action is basically when do you create a new index, and then that will influence like A, the indices should be evenly sized, and B, it will play into the retention, because after that rollover, only then can you say like, okay, now I want to get rid of this chunk of data, or how long do I want to keep this chunk of data around. Force merge is an action that you can do to actually optimize the data structure. By the way, you can run this force merge either in the hot phase or in the warm phase. So you have to force merge here as well. You would pick either one of them because you only need to force merge once. The question here is more like, on which nodes do I have more capacity available to do that heavy force merge operation? Either on the hot nodes, because you say these are the nodes that have more resources, or you say I want to do it on the warm nodes because they're not as busy, because all the write operations happen on the hot nodes, and warm will only be read only. So that's up to you to decide. So these were the actions for hot. On warm, you can see that we have a lot of the same actions, by the way. So we have priority, we have unfollow again. What you do here is you set the index read only because you're not writing any more documents to it. This is just another way to optimize how we can treat the index structure. You can allocate it. Allocation basically means moving it to another node. So that allocation step here would move it from a node that we say this one is a hot node, and this other node here is a warm node. And that allocation basically means moving the data from hot to warm. You could shrink the number of primary shards, just like how many pieces the index is made up of. By default, right now it's 1. If you have a more complicated index structure, you would need to or could change it here. And then the force merge that I've already described. Then we get to the cold nodes, so the more long-term storage. Here you can, again, you have priority, unfollow, you have another allocation. So this would move the data from a warm node to a cold node. You can freeze your data. I will show you a bit more about freezing it later on. It reduces the memory usage of your indices quite a bit. And then there is searchable snapshot action. I will briefly touch on searchable snapshots only because this is a feature that is not out yet, but will come in the next minor release, and the ones after that, we will keep adding more features to that. Finally, we have the delete action. The delete action, we can wait for a snapshot. This is basically just taking a final backup of the data before deleting it, and then actually deleting the data. So these are all the different steps that you can take. And maybe now is actually the time to show you what I'm putting together here. So the demo I'm running, I'm using Go Simple. So I have on one physical machine, I have 3 Elasticsearch nodes. One is a hot node, and then we have a warm node and a cold node. So we have one node for each of these lifecycle steps, basically. And then I just give each node half a gig of heap, and the entire instance or container has 1 gigabyte of memory. And then I basically just make sure that this hot node sees the warm and the cold node, and they form a cluster. That's pretty much. And then I have the same thing for a warm node. So this is the warm node, and then we have a cold node, again, the same thing. Then I have to actually manage that and see what is going on here. And then I have a short-lived container to configure everything. I will show you a few of the configurations options in a moment. And finally, we have metric beat. Metric beat is just monitoring that host and the containers and generating the data. So this is basically driving the demo, because this will generate all the data that we have for monitoring it. So what have I set up? I have set up a custom index lifecycle management policy here. And I will show you the JSON, because that is basically the truth. I will also show you how to do that in Kibana in a more visual way. But this is how I'm using this and how this is set up. Before I dive into the details, these are demo values. You don't want to use these rollover values for production because they are way too small. I'm just picking very small numbers here so that you can actually see data move around in the cluster. Because normally if you would wait to reach 50 gigs of data or 30 days of data to have a rollover action, you wouldn't see anything in this demo today. So I have picked very small values, which are good for demos, but bad for production. Please don't use those for production, because they will make your system very slow, because it will just be busy creating those very small units of data that don't make much sense. So what I'm doing here is I'm defining a hot phase. And in my hot phase, I'm creating the rollover action. So as soon as I hit 5 minutes or 5 megabytes on that index, I will create the next index. In the warm phase, 5 minutes after this rollover, based on these conditions happen, I make the index read-only. I move it to a warm node. I force merge it down to a single segment. I shrink the number of primary shards to 1, and I reduce the priority. 10 minutes after the rollover, I'm moving into the cold phase, and I'm actually moving the data to the cold. I freeze it, and I reduce the priority further. And 20 minutes after the rollover, I take a snapshot that I take every 10 minutes, and then I actually delete the data. So how do my nodes know what is cold and what is warm and what is hot, and where should my index go initially? So in the Docker Compose file, one thing that I haven't really pointed out here is there is this attribute, node name, node attribute size. This is the attribute. This makes sure that this is basically tagged as a hot node, and this other one here as a warm node. And this is what I'm using in these lifecycle steps to make sure that the data then moves from the node that is tagged with hot to one that is tagged with warm and then cold. How do I make sure that my index initially gets to a hot node? For that, we have an index template. This one here. So here, since I'm collecting that metric beat data, so the CPU and memory usage of my system, I'm making sure that this gets allocated to this hot node. Also, I'm saying that this one has 2 primary shards that will be reduced down to 1 as we go along. It doesn't have any replicas, but it does apply this lifecycle policy of metric beat. This is the one that I've just shown you that was this ILM policy. So this is what we have applied here. Just as a pointer, because otherwise you might run into this, generally the index lifecycle policy does not get updated that frequently. If I remember correctly, it's every minute or every 10 minutes. And normally that's more than enough. For my example, to actually keep data moving around quickly enough, I set it to 5 seconds. So it will check the ILM policy every 5 seconds to make sure the data keeps moving around. And that's pretty much all you need. So let me switch over to Kibana. I have started all of this, so hopefully it was always the demo effect. Let's reload Kibana because I've just started all of the components fresh. Let's see how it is loading. Hopefully it is. Okay, it looks like it's here. I'm not sending any stats for this now. Where we want to head first, if there is something called stack management. And in stack management, we have index management. And this will show you what we have created here. And you can see we have multiple indices and they are numbered. So we have metric beat, dash, and then 0, 0, 0, 0. So this one was the first one that was created. After the first rollover, we got one with 1, then 2, and 3. So this is the one we're currently writing to. And you can see this one here has already been renamed to shrink. So we reduce the number of primary shards from 2 to 1. Then they are renamed with that pattern. Also, you can see how many documents are in them and how large they are. So these one here have been rolled over after 5 minutes or so that they ended up with this data size. And this one here is already frozen. So this is in the cold stage. This one here is probably still in the warm phase. These two are in the hot phase. And this one here will soon move from hot to warm. Then it will also be shrunken down. And after that, this one will move to the frozen stage. And 20 minutes after rolling over, this one here will be deleted. So at the end, when I show you that page at the end again, probably this one with all zeros will be gone. And we will have more and more other indices. So as I keep reloading that, you will see here the number of documents keeps increasing and the size. And after some time, we will roll over to one that has the number 4 at the end. So these are all this is ILM at work. Just very quickly, because normally it would take much longer, but for the demo to make sure you can see something. We also have a tab Index Lifecycle Policies here. The one that I'm interested in is metric beat, and you can see it is actually managing 4 indices right now. And opening that, you can see these are the conditions that I have defined in the JSON. So after 5 megabytes or 5 minutes, we will roll over to the next index. Then 5 minutes after the rollover, we're actually moving that to a warm node. You don't probably see that here, but this should say warm. This will be moved to a warm node. We're shrinking down from 2 primary shards to 1 primary shard. We're force merging to a single segment, and we're changing the priority. Then we have the cold phase. 10 minutes after the rollover, we will move the data to a cold node. We keep everything like this. We just freeze the data. And 20 minutes after the rollover, we are actually deleting it. First, we take a snapshot, then we delete the data. One thing that sometimes confuses people is what if I misconfigure this and I say like, here I say 15 minutes after the rollover. And what happens if I keep 10 minutes after the rollover here? Can the cold phase overtake the warm phase? No. The cold phase will only ever kick in after the warm phase has been finished. So one phase cannot overtake the other one, even if you misconfigure it. It wouldn't make much sense. It needs to be hot, warm, cold, then delete. It wouldn't make sense that the delete could overtake the warm or the cold phase, for example, because there's nothing to do anymore. So this is what we have set up here. Yeah, like I said, the minimum age is if you use rollover, it's the time when the rollover happens. If you have, if you're not using rollover, it is actually the creation date of the index that will be used for that. And like I said, the previous phase must have finished before we go to the next phase. If you have used Elasticsearch for a longer time, there is this thing called Elastic Curator, which is a Python tool to actually do that. What is ILM doing for you now? It used to do that. Curator is still around. It is more powerful, but it's a bit like an 80-20 thing. Like ILM tries to cover 80% of the use case with 20% of the complexity of Curator. Curator is much more complicated, and it has a downside that it runs outside of your cluster, whereas ILM just runs part of your Elasticsearch nodes. So you don't have any external piece of software, which especially makes sense since we offer a cloud service for Elasticsearch. And we always had to tell people, well, you need to run your own Curator on a virtual server somewhere. Wasn't very sexy for a cloud service, so that is where ILM is still there, or makes more sense for that. However, Curator is more powerful if you have more complex rules around, like I have some complex aliases that I need to set, or I want to have more complex rules when something should happen, or depending on the size or on the day or time of the day. Those are things that Island does not cover, at least not yet. So there might be reasons when you still need to use Curator. But if you don't need Curator, stick to Island because it's easy to set up. It has a UI. It runs part of the cluster. Next up, something I haven't really touched on too much yet is Snapshot Lifecycle Management. Again, this is all configured through JSON, but to keep it simple, I will just show you that in the UI. So here we have Snapshot and Restore. So when I say Snapshot, it's basically taking a backup of your data. And I have a repository. My repository is a shared file system. Since all those Docker containers are running on the same host, it's easy to have a shared file system there. You could use any blob storage as well, like Amazon S3 or whatever blob storage the other cloud providers have. So there needs to be one shared file system that everything can use. NFS, S3, whatever. Then I have a policy. My policy is called 10-minute snapshot, which unsurprisingly takes a snapshot every 10 minutes. So far, I have taken 2. So I have obviously been demoing this for 20 minutes or so already since we have taken 2 snapshots. This just uses a cron syntax. So you can see this is how often we want to run this every 10 minutes. We are taking all the indices that we have. We are putting that into the repository I have configured, and this is the name that I will be using. So this will show a nice timestamp of when the snapshot was actually taken. And in the history, you could see that the last successful one was a couple of minutes ago, like almost 10 minutes ago. So we are about to take another snapshot now. Okay, in the snapshots, you can see these are how many snapshots we have. And you can see now the third one right at this time now has just happened. We can click on that one to see the details. It will tell us, okay, the snapshot is complete. These are all the indices that we have been taking a backup of. The ones that you will mostly care are these, so the metric beat and the metric beat shrink. And you can see we are at index 4 already. 000 is still around, but will be deleted probably pretty soon. And this is just a backup that you could restore to the same cluster or another cluster if anything bad happens to your cluster or data. Okay, we've seen that. Next up, cold storage. Cold storage is basically the idea you have something that you need to keep around for a long time, maybe for policy reasons or for legal reasons. And what you generally want to have is you want to reduce the ratio of heap to storage. So an index uses a bit of heap all the time just to keep your data quickly accessible. You can also close an index. Closing an index basically just leaves it on disk but reduces it to 0 in-memory data. But you have to explicitly open an index, so there is an API endpoint and you can just call close or open, underscore close or underscore open on the index, or a list of indices or a wildcard. To close them, that will take a little amount of time to actually make it accessible. So what we have added here is a so-called frozen index. And a frozen index tries to be in between. It's behaving like a closed index, as it does take no or very, very little memory generally, but you can dynamically open it for searching. So you can just access it. It will basically be opened, searched, and then closed down again, more or less, to keep it simple. It has 2 trade-offs or 2 attributes. First off, data needs to be read-only to be frozen. That's one of the preconditions. And it takes almost no memory. So how do we access that? There is a dedicated thread pool to actually access those cold or frozen indices. It is a bit conservative. So what we have is 1 parallel search per node, and you can queue up to 100 search operations. So if you are doing a search operation that tries to search 5 frozen indices, you would go into the first frozen index, search that, then go to the next one, then go to the next one. It's basically open it up, searching it, closing it, and going to the next index to do that. And you can queue up to 100 operations to have queued up to be taken care of. If you try to do more in parallel, those would be rejected. So it might take a little while until all your parallel searches are being done if you search lots of frozen indices. So let's take a look at frozen. And we're using that in the background already, but to keep it simple, I will just create a new index to show you frozen in action and like some of the trade-offs around it or how it behaves. So the first thing I'm doing is I'm creating an index called frozen. I hope this is large enough for you to read. So we have a frozen index. I'm allocating it to the cold node because that's where it makes sense. I'm not allocating any replicas because I don't need them here. We have created the frozen index. Next up, I am creating two documents. I'm creating somebody called Philipp and somebody called Nicola. So we have two people in that index. When I search the index, we will find those two documents. And these are the two documents that we have found. Now, I want to freeze that index. Before you do that, you should force merge it. This is just to optimize the data structure, how it's stored in the background. So it will be more performant to search it afterwards. So I force merge it and then I freeze it. So on the index frozen, I underscore freeze endpoint. This actually freezes it. Now, what do you think happens if I try to search that frozen index? And this will probably surprise you or is a bit unexpected. If I search that, it doesn't say the index doesn't exist. It just doesn't give me any results back. Why is it not giving me any results back? The idea is to protect you from doing an expensive query accidentally. You need to add this parameter, ignore throttled false. Only then will it show you those documents that you have in there. So again, this is just a precaution basically that you don't run an expensive search operation accidentally. So you need to pass that parameter. You can also look at the parameters of this index frozen. If I search for that, it will just tell me this is the frozen index. It has one primary shard, 0 replicas, 2 documents into it that take 4 kilobytes of data, which will probably be mostly metadata. And it's actually a green, so it's going well for that index, but it says it's open, which might be a bit confusing. So that the status doesn't change to frozen, but stays open. I will show you the setting in a moment, how to actually figure out if it's open or open frozen. You can check out the thread pool. The thread pool, to make this more readable, you can see here on the cold node, we have completed one search operation against the frozen thread pool or the throttle thread pool. That was the one search operation that we were doing here. The one where we didn't pass our parameter didn't cause anything here, so they are not in the rejected. This is just for the thread pool, how that one is doing. How many active search operations against the frozen index are running, how many have been rejected, how many are currently queued up, and how many have been completed. What you can also check out is here I'm running an optimization that you don't really need. What I'm wanting to do instead is so this one here basically would make sure if you search lots of frozen indices, this pre-filter would make sure that you only access indices that can match your data. So if you have, for example, a time span that you search, and an index knows my data is only from this point in time to this point in time, and you're searching for another time frame, it would not even try to open the index for searching, it would just skip it. And by now, this pre-filter shard size 1 is actually the default, so it's in there implicitly once an index is read-only. So that is an optimization that we run. Otherwise, only when you try to search 128 indices or more, this optimization would kick in. It's basically another round trip before you do the actual search operation. Probably going too far for today. So what happens if I try to add another person to the index? It will be rejected because it tells me, well, that's a frozen index, or it just tells me it's an index that is not writable right now because, well, it's frozen. So now, if I check the settings of that index, I can actually see those non-default settings that I have on this one. And don't be confused. This is the name. This is the setting that we're after. So index frozen true, that is what tells you that this is a frozen index and not a regular open index. This is where you can find that. So to write or add another document to that, you would have to unfreeze it. So this is how to make it a regular index again. And then I could just add this new document to it. And then if I search it, now obviously I can search it in the regular way again. Now I have 3 documents in that index and it's a regular index again. So this is the frozen index in the background that is happening. By the way, one thing, if you want to access any frozen indices in Kibana, you have in stack management in advanced settings. There are quite a few settings by now. Luckily, you can search for them. By default, any frozen index would be ignored in your search operations. But you can turn this on, and now Kibana will also show you the data of frozen indices, which might just make your searches a little slower. That's why it's off by default, because there's this special way to only access one frozen index in parallel per node by default. And this way we could access our data. Now, let's see how the data in our cluster is actually going. Since I'm also accessing frozen indices, this might take a little longer. And since this node in general has very little CPU and I run Kibana, 3 Elasticsearch nodes and metric beat on it, it might be a little slow to load this. But I would just let that sit in the background or trigger a refresh on the page. And when we come back to it, it should have some data. This will just show you what is going on this node in terms of all the containers that we are running. But like I said, the first time you're trying to run this, it might not be cooperating. Or it doesn't like me right now at all. I'll try to reload that. We will get back to that in a moment and see if that is actually showing me what I want. Yeah, I've shown you the pre-filter shard size is basically adding a round trip and skips shards that cannot hold any data. So especially if you have a data range filter and the shard knows I only can contain data for this period of time and you're searching another period of time, it will very quickly skip that entire index and not try to search it. One thing that we have coming up are searchable snapshots. So the snapshots are the thing that where you take basically a backup of your data and you can store it on Amazon S3 or any other block storage to make that searchable as well. That will have an additional overhead because you actually need to fetch some data from S3, but it will make your snapshots searchable and you don't need to keep it around on any actual node. This one is the only feature that I'm showing you or discussing that is not free. Since this is not out, I don't want to dive into the licensing. We will see once it comes out. But it is basically around the corner to have these searchable snapshots available in the stack. So that will be a paid feature from what I know. So final thing to optimize your data are rollups. So the idea is if you have metrics and you collect metrics maybe in 10 intervals, and after a week, you might say, okay, maybe I only need 1 minute intervals. And after 2 weeks, you might say like, maybe I'm fine with 1 hour intervals. So you want to pre-aggregate those time slices together. And obviously, it will save you a lot of data in terms of size because you just reduce many data points to very few data points. And that's what rollups do or give you. So let's look at what we actually have here. Okay, now in the background, my Docker dashboard has loaded. You can see we have 5 running containers. So it's 3 Elasticsearch containers, 1 Kibana instance and 1 metric instance, and then 1 stopped one that was the one to set everything up. And you can see how many resources each one of those take. And you can see in terms of CPU, I'm pretty much at the limit for my Elasticsearch nodes. So all of them are at more than 90% memory usage and also CPU usage. This one, the hot node that actually does all the write operations, that one uses more CPU than it should. That's why this one seems to be pretty busy. So maybe we need to give it some more resources. And here you could see, for example, how are we doing in terms of memory use and how are we doing in terms of CPU use and how spiky is it. and also in terms of network traffic, how much data is being moved around between my nodes. So this is just a dashboard to show you what we have in that index or on those nodes. So when I go back to stack management and go back to the indices, one thing that I need to explicitly enable here, and by the way, you can see that metric beat 0, 1, and 2 is still there. 0 and 1 have been deleted. 2, 3, and 4 are frozen. 5 is in warm, and 6 and 7 are in hot right now. So data keeps moving throughout my cluster. But what I want to show you here are the rollup indices. So here I have a rollup index, and this one has data points for all those frozen, but even the deleted indices. And it only contains 5 documents, and you can see it's much, much smaller than the others. What have I configured here? Again, do you want to see the JSON, or should I show you in the UI in Kibana? I'll show you the JSON because that's kind of like truth. So in terms of rollup, this is what I have configured here. So I'm taking the metric beat data and I put it into an index called metric beat rollup. It is slightly larger, so hopefully it's readable. Then you can see that cron is running every single minute, and you can see I'm basically aggregating together 5-minute intervals. And those 5-minute intervals are based on the timestamp feed. And then I just take 2 fields, the Docker network in and the Docker network out. And for those, I calculate the sum of data transfer and the average. And those are the only 2 things that I store for those rolled up data or documents. So out of all normally I create or collect data every 10 seconds. And now what I'm doing is I'm just taking 2 of the available fields and just create those 2 calculations for 5-minute intervals rather than 10-second intervals. And that's why I have so much less data here and only 5 documents rather than all the other documents. What is very nice about this is that you can even mix rolled up data and live data. So you could have a single dashboard that shows you going back all the way to however long you have collected data with the rolled up data. And for current data, you just show from a current index the data. The limitation with that is, though, that the granularity is limited by the rollups. So if you have 5-minute intervals here, you can only have a data point every 5 minutes and not have more fine-grained intervals because otherwise your graphics would be off. But this way you can save a lot of storage to keep metrics for a very long time rather than wasting a lot of disk space. Obviously, this only works for metrics. You cannot aggregate logs that easily and roll them up into 5-minute intervals. That's unfortunately not possible the way that logs work or traces. Metrics can be easily aggregated, and that's what we are doing here. Just one side note, right now, rollups are still a better feature, and we are in the process of rewriting the internal implementation to make some improvements. So it will, in some later version in 7.x, there will be a version 2 rollup interface that will make quite a few improvements internally, but it will work the same way. So it will pre-aggregate metrics and just store those aggregations rather than all the raw data points. Okay. So I think time-wise, we are almost at full hour, so it's time to wrap up. If you want to try this out, on my GitHub account, scale Elasticsearch, clone the repository, Docker Compose up, it will pull all the necessary containers and it will automatically set up everything that I have shown you. There is nothing else to do. You can just then watch the data as it goes in and move throughout your cluster. What we have covered is lifecycle management, what was index lifecycle management, so to move data to different nodes and delete it at the end, and snapshot lifecycle management to take snapshots every now and then. Also, those will be cleaned up automatically. So I'm keeping 2 to a maximum of 5 snapshots with a timeout of 30 minutes or so. All very much demo values, but you can pick the right ones for production. Cold storage, the idea was to make it cheaper to keep data around for longer, trading memory or using less memory to keep your data accessible, which will make it a little bit slower, but cut or reduce your costs by quite a bit. And then rollups, if you have metrics, you can roll them up into bigger slices of time just to have fewer documents and save disk space, and also make it much easier to show like the average network traffic that you had per hour for a full year, which might be or is doable if you have 1 hour intervals or so. 10-second intervals might just be too much to show on a dashboard. And also, if you show a full year, you don't need that granularity anymore. You wouldn't see it anyway. If you want to get all of that as a service, we have our cloud service, Elastic Cloud. There you could just say, like, give me a hot, warm setup, and it would provide the nodes with the right tags and everything for you. And you could just click together like, okay, please push my data there, and then it will move through the right phases. And Kibana will let you configure everything as needed. And that's it. If you want to get the slides, that QR code will get you to my website where you can get the slides. And with that, I think we can head over to the questions. We're pretty much exactly at the hour, so we should have 5 minutes to answer any questions that you have. I hope there are some questions. Let's see.
You've done?
Thank you. Yes.
So you hear me?
Yes, now I hear you. Sorry. Initially not, but now.
Great. I said thank you for the amazing talk that you've done, first of all.
Thanks a lot.
And we've got the first question, so I'll start. The question from Pavlo. Hi, Philipp. Thank you for your presentation. Which Helm chart is better to use for provisioning Elastic in Kubernetes? Official Helm chart has hard-coded node roles like data, client, master, but it takes a big amount to run all roles nodes. Is this a good practice, or you could recommend a better Helm chart?
Okay, so there's a pretty specific question. Let's try to cover it. So if you want to run Elasticsearch on Kubernetes, you basically have two options that we provide. We have Helm charts and we have an operator, which we call ECK, Elastic Cloud on Kubernetes. So you can either use the Helm charts or the operator. Both are GA, both are officially supported. The operator is probably a bit more powerful, but both should allow you to combine roles. So you could just have a 3-node cluster or to split out the roles of each node. So you could have dedicated master nodes, and you could have data nodes, and you have ingest nodes, and maybe client nodes. So you can break those out. Normally, the role a node has, you would specify when you start up the node. So when you start it up, you could provide the full list of 1 or more roles that a node has. If you have just a small cluster, like a 3-node cluster, it would probably have it normally has all the roles. So it would be a master node, a data node, an ingest node. If you have machine learning, it would be a machine learning node, and you would have that. If you have a larger cluster, you have 10, 20, 30 or more nodes, you would break out specific roles. Then you could have a dedicated master node. You would have some nodes that are only data nodes, and potentially some that are either ML or ingest nodes, depending on if you have or use that. But the Helm charts shouldn't stop you from combining the roles. So it shouldn't stop you from combining roles, but having to specify the roles of a node up front is not uncommon, because it will just enable the specific features. So that will be hard-coded and baked into the node. You cannot turn a master node into a data node at runtime easily. That won't work. You would need to restart the node anyway, because that's just baked into the configuration. I hope that answers the question.
I hope too. Thank you. So another one, another question. I've heard that Elasticsearch cluster breaks sometime. You should have been in a situation when a cluster gets randomly broken. What were the most popular reasons for you? How to avoid or make restoration easier?
Right. So I think part of that question is like old versions, because, well, Elasticsearch by now is pretty much exactly 10 years old, depending on what version you were using. We have made quite a lot of improvements over time of things that were breaking and shouldn't break anymore. For example, one of the main things that were happening in the past was the clustering. where since the way that Elasticsearch forms a cluster is a so-called quorum. So for example, for master nodes, you need to have, or you want to have 3 master eligible nodes that can form a quorum around voting for that. In the past, if you set that up wrongly, you could easily break your cluster. Though, for example, in 7, the entire setup around that changed, so it's not that easy to break your cluster for that anymore. Other than that, it's mostly, I think, monitoring. So if you push your nodes over some limits in terms of CPU and memory, obviously it will break the cluster at some point. So I would just be careful, use a current version that will avoid a lot of the problems. Monitor it and then follow things in terms of best practices. So don't use stuff like NFS or so for the storage, because that will not work so well. Give it the right amount or the necessary amount of heap, and 50% for the heap, 50% for file system level caching of what you have available on the Docker container and stuff like that. If you have a specific problem, we can discuss that, but it's very hard to say, like, in general, what might have caused the issue there. I hope that helps.
Thank you. So I saw somebody was typing but not sending the message, so I'm not sure if this person decided to ask you a question or not. So I guess if we have some more questions to you, we can send them to you and you may reply in text and we'll send it.
Sure, or you can just ping me on Twitter. My handle was Xera, so XERAA. You can ping me there anytime and I'm happy to answer, or forward me questions afterwards and we can see what we can do there.
Okay, and there's one, I think, last question coming finally from Pavel. Do you have some recommendation for running Elastic on EC2?
Well, if you run it on EC2, that's totally fine.
He means tips and tricks. Sorry for interrupting. Tips and tricks.
Tips and tricks on EC2. You mean around discovery? So there is one plugin for discovery to form the node. So EC2 in general, so Amazon EC2 change all that much. The 2 things I think that we would generally point out is there is a plugin for discovery, because the IP addresses or DNS names might change more dynamically. So you want to have a different way for discovery of the other nodes in the cluster. There is an EC2 plugin that you can use to actually do that discovery more easily on AWS. The other thing is the storage. At least in the past, we were a bit careful with EBS, the network attached storage that you would get on AWS, and we're going more for instant storage because it was more predictable in terms of performance and also less prone to having outages. EBS will also work. If you can do fast instant storage, it will be probably better though. Generally, watch your I/O. That's one of the things that might break, and like also depending on the instance sizes and everything, watch your CPU. If you hit a wall because you run out of CPU credits for like a T2 instance, for example, your cluster will not have a good day. So I think those are the main takeaways for running it on EC2. But otherwise, there are plenty of people doing that. There's nothing wrong. You can, of course, use something like ECKK if you're running on Kubernetes, but you don't have to. You can just run plain nodes on AWS, EC2.
Okay, thank you so much, Philipp, for spending your time today here. It's been really terrific. And people, if you have any questions or want to talk to Philipp, please ping him on Twitter. And Philipp, I hope to see you really soon in Kiev when it will
hopefully, yes, in Kiev and in person again, yes. Yes. Thanks a lot for having me. Enjoy the rest of the conference. Bye, everybody.
Thank you. Bye-bye.